Okay, 4.3 practice A. As promised, I'm going to review all your worksheets to help prepare you for the test. So none of you can complain and say that it's because I didn't teach you how to do the stuff that's on the worksheets or on the test. Here's looking at you, Scoot. Angle N and angle P. These are not corresponding angles. And you know that because this only got 2 swoops on it and this got 3. So that would be neither. Angle M and angle P, that's got 3 swoops. And this one's got 3 swoops. So it would be CA, or corresponding angles. OM and RP. See, OM goes from the one that's got 1 swoop to 3 swoops. RP is 1 swoop to 3 swoops. So that would be corresponding sides. And NO and QP, 2 swoops to 1 swoop, 2 swoops to 3 swoops. No bueno. So that's neither. Jerry. Decide whether the congruent statement is true. Explain your reasoning. So, how do you know that IHJ is congruent to JHK? So IH has the 2 little markings, so does HK. IJ has the 1 little marking, so does JK. Just kidding. The JK and IJ both got the 1. Then JH is the same as JH because of the reflexive property. So anytime you see this line connecting the 2 triangles, you know that you're going to use the reflexive property, and that side is going to be congruent to itself, which means side, side, side works for us. All right, look at the next one. We have LP and LPS congruent to PLN. Well, LN is congruent to PS, LS is congruent to NP, and LP is congruent to itself. So that would be side, side, side. Number 7, ACE congruent to BDF. So AC congruent to BD, no, that doesn't work because AC is congruent to BF. So that would be, no, not true. Number 8, STV. That would be ST and UT. Those are congruent to each other. SV and UV are congruent to each other. And CV is congruent to itself. So it would be side, side, side. Pretty easy so far. Decide whether the figure is stable. Explain your reasoning. This would be yes, because it's congruent triangles. This would be no, because it could tilt over. So use the given coordinates to determine if triangle ABC is congruent to triangle DEF. This is really the only hard part of the entire section, because we have to use the distance formula for a bunch of these. It's still not that hard. Okay, so we have to measure the distance from A to B. So AB is equal to the square root of 2 minus 1, which is 1 squared, plus 0 minus 1, which is negative 1 squared. That gives you the square root of 2. Now, before we move on to BC, let's try and see if DE is exactly the same. If it is, then we can move on. But if not, then you know they're not congruent right away. So let's move on to DE. 4 minus 3 is 1 squared. And 0 minus 1 is negative 1 squared, which gives you the square root of 2. So far the 2 triangles are congruent. Now we're going to check BC. BC equals the square root of 1 minus 2, which is negative 1 squared, negative 1 minus 0, which is negative 1 squared. That again gives us the square root of 2. Now let's check EF. EF equals the square root of 3 minus 4, which is negative 1 squared, plus negative 1 minus 0, which is negative 1 squared again, which is the square root of 2. So far they are congruent. Last one you have to check is AC. AC, you have the square root of 1 minus 1 squared, which is just 0, so you don't even have to write it, and negative 1 minus 1, which would be negative 2 squared. That gives you the square root of 2. And DF equals the square root of 3 minus 3, which is 0, and negative 1 minus 1, which is negative 2 squared, which is square root of 2. So they all matched up. AC was the same as DF, BC the same as EF, and AB the same as DE. So this would be yes. Number 12, got to go down the same road. Okay, AB equals 4 minus 1, square root of 3 squared, plus 1 minus 2, which would be negative 1 squared. It gives you square root of 10. And DE is equal to the square root of 1 minus 2, negative 1 squared, plus 8 minus 5, which is 3 squared. That equals square root of 10. Now we have to try BC. That's 4 minus 1, which is 3 squared, and 3 minus 4, which is negative 1 squared. Gives you square root of 10 again. Now you got to compare that to EF. EF equals 6 minus 8, which is negative 2 squared. And then 4 minus 1, which is 3 squared. It gives you 4 plus 9, which is the square root of 13. You can stop right now. Square root of 13 is not equal to the square root of 10, so that would be no. Number 13. Determine whether triangle ABC is congruent to DEF. Explain your reasoning. Blow this up. Get rid of that. This out the way. Right, there we go. AB is the same as DE because they're both 4. So far so good. BC is the same as FE because they're both 6. Now this middle FC is the same on both triangles, right? So all you have to do is check to see if this little extended part is the same. And it is. So those middle ones are congruent. So that would be yes. And your reason is side, side, side. Next one, we got 10 and 10 for AC and DF. We got 6 and 6. Then we have 3 and 2. So this line is not as long as this one, which means it's no. Two different gate doors are shown below. Anytime you see the congruent triangles, that's all you really got to say. All right, A's done. Time to move on to B. Tell whether the congruent statement is true. ABD and CDB. AB is the same as CD. BD is the same as DB. And AD is the same as BC. Tell because those markings. So yep, and side, side, side. Number 2, RST congruent to RQT. You got RS congruent to RQ. ST congruent to QT. And then this third side is congruent to itself. So yes, by side, side, side. Lastly, we have AB congruent to DE because there's 3 and 3. We have BC congruent to EF because there's 2 and 2. And AC congruent to DF because it's 1 and 1. So that would be side, side, side. Okay, you use the given coordinates to determine if ABC is congruent to DEF. Good, there's 4 of these problems instead of 2 on this one. That's what I like to see. Let's jump down here first. Stable. No. Because this figure needs to be cut in half. And this one is actually a no as well. And the reason is because you don't have congruent triangles in here. Plus, the triangle that is in here is going sideways. Alright, let me draw my box to do my work in. Dang, that's embarrassing. All right, number 4, you have AB so that's 4 minus 1, which gives you 3 squared, and negative 3 minus 2 is 5, negative 5 squared. So that gives you 9 plus 25, which is the square root of 34. And we have DE, which is equal to 7 minus 4, which is 3 squared, and then 2 minus 7, which is negative 5 squared, which gives you the square root of 34. Move on to the next one, it's BC. Do 2 minus 4, negative 2 squared, and 5 minus negative 3, which gives you 8 squared. That's going to be 4 plus 64, square root of 68. I'll check EF. Do 5 minus 7, that's negative 2 squared, plus, you do 10 minus 2, which is 8 squared. It's going to give you square root of 68. So far so good. third side, AC. AC is equal to 2 minus 1, which is 1 squared, plus 5 minus 2, which is 3 squared. So it's equal to the square root of 10. Then you check DF. That's 5 minus 4, which is 1 squared, plus 10 minus 7, which is 3 squared, gives you the square root of 10. So it's good. Yes, side, side, side. Number 5. AB, DC, AC. I'm not going to do them in that order, I promise you. DE, EF, and DF. So AB is 4 minus 1, which is 3 squared. I'm not going to continue to do the work either. 4 minus 1 gives you 3 squared. 0 minus 1 gives you negative 1 squared. That gives you the square root of 10. DE, negative 6 minus negative 5. Maybe I will do the work. Negative 6 minus negative 5 gives you negative 1 squared. 6 minus 4 gives you 2 squared. That gives you square root of 5. That's not 10, so that's no. See why I didn't do A, B, B, C, A, C? Because I would have had all 3 of these done before I ever started and saw that this was square root of 5 and it was wrong. So it would be my 4th part of the question before I ever figured it out. So make sure you're doing it in the order that I am. Number 6, 2, negative 2, and 5, 1. So you do 1 minus negative 2, which gives you 3 squared. Then you do 5 minus 2, which gives you another 3 squared. This gives you square root of 18. Jump to DE. I got 8 minus 5, which is 3 squared, plus 10 minus 7, which is another 3 squared. So it's square root of 18. BC is 8 minus 1 squared, which gives me 49, plus 4 minus 5, which is negative 1 squared, square root of 50. EF is negative 1 minus negative 6, which is 5 squared, and then 9 minus 6, which is 3 squared. 5 squared is 25, 3 squared is 9. So you get the square root of 34. So that would be no. 50 is not equal to 34. Number 7 goes 2 minus 0, which is 2 squared, plus 6 minus negative 3, which is 9 squared. Which is square root of 85. DE, negative 8 minus negative 10 gives you positive 2 squared. 13 minus 4 gives you 9 squared. You can tell right now it's going to be exactly the same. BC, you do 9 minus 2 squared, which gives you 7 squared. Then negative 1 minus 6, which is another 7 squared. Which gives you the square root of 94. Right? 49 and 49? No. 98. Then for EF, it's 13 minus 8, which is 5 squared, plus 9 minus 1 squared. 9 minus 10 squared, which gives you a negative 1 squared, which is the square root of 26. 98 is not equal to 26. So that's also a no. That was fun. Now we did 8, 9, and 10 already. Number 11. AB is 10. DE is 10. AC, same as DF. And EB and BC, EB and FC are the same, and BF is the same. So that would be yes, and side, side, side. Number 12, AB is the same as DE. AC is the same as DF. But then BE, or BC is not the same as FE. And the whole reason is this one's got 2 on the end, this one's got 1. Number 13, complete the proof. AB is congruent to CD and BC is congruent to AD. How do you know AB is congruent to CD? Well, it's got this marking on it, right? AB congruent to CD like that. Plus it says given. That's where we start, given. And BC is congruent to AD. Look at that, that's also given. And how do you know that this middle thing is congruent to itself? AC congruent to AC, that's reflexive. Now, can we say that these two triangles are congruent? Yes, because all their pieces are congruent to each other. CD is congruent to AB, AD is congruent to BC, and AC is congruent to itself. So the two triangles are congruent, and the reason is side, side, side. Number 14, complete the proof. AB is congruent to CB. We know that because it's given to us. And it says D is the midpoint of AC. Also given to us. Then AD is congruent to CD. That's by definition of midpoint. BD is congruent to BD. So we said AD is congruent to DC. How do you know that this is congruent to itself? Reflexive property. So then we have side, side, side. All three sides have a marking. Picture frame. Backs of the two different picture frames are shown below. Which picture frame is stable? It's the one with the two triangles in it. Alright. See, number 1. ABC is congruent to triangle FED. AB has the 3 markings. FE has 3 markings. Then BC is made up of 2 sections that each have 1 marking. ED made up of 2 sections that each have 1 marking. Then lastly, AC is congruent to FD. This little section's in both of them, so it's congruent to itself. And then you have congruent pieces outside. So yes, side, side, side. This one, LM is 9. UV is 6 plus 3, which is 9. Then do MN, which is 5 plus 6, that's 11. That's congruent to VW, which is 11. And lastly, you have LN and UW. LN is 5, and UW is 5. So it would be a side, side, side. PQR and RTS. PQ is the same as RT. They both have 3 markings. QR has 1 marking. TS has 1 marking. And then PR and RS each have 1 marking. So that would also be side, side, side. Number 4. AB and DE got to relate to each other. So AB equals 1 minus 3, negative 2 squared, plus 4 minus 1 squared, which is 3 squared. This gives you the square root of 13. Check DE. Negative 5 minus a negative 3. That gives you negative 2 squared. Then 6 minus 3, which is 3 squared. So that gives you square root of 13. So far, so good. Depends how you look at it, actually. I mean, it'd be good if we were done. So BC, 3 minus 1 is 2. So it's 2 squared plus 5 minus 4, which is 1 squared, which is square root of 5. EF is equal to 7 minus 6, which is 1 squared, plus negative 3 minus 6, which is negative 9 squared, which gives you the square root of 82. That's going to be no. All right, number 5. Oh, man. Number 5, we got 2 minus negative 1 gives me 3 squared, plus negative 2 minus 1 should be negative 3 squared, which means we're at the square root of 18. Then for DE, negative 1 minus 2, so negative 3 squared. Then 6 minus 3 should give you 3 squared. So that's the square root of 18. BC, negative 4 minus 2, that gives you negative 6 squared, plus negative 3 minus negative 2, negative 1 squared, That gives you square root of 37. EF, 5 minus negative 1, gives you 6 squared plus 7 minus 6, which is 1 squared. Gives you square root of 37. Gotta keep going. AC equals the square root of 4 minus 2, which is 2 squared, negative 3 minus negative 3, which is 0 squared. So this gives you the square root of 4 with 2. DF is negative 7 minus I just got so lost in this question. Where we at? We're here. Yeah, we're on number 6, right? I hope so. 6 minus negative 3, yeah. Oh, we're only on number 5? That's garbage. Wow. Alright, anyways. Negative 3. Hold on. Alright, my AC, I moved on to number 6. It's just wishful thinking. Alright, let's figure out AC again. Negative 4 minus 2. That gives me negative 2 squared. No, it doesn't. Negative 4 minus 2. That'll give me negative 6 squared. I don't need to do that. I'm on AC. Negative 4 minus 1 minus a negative 1 gives me negative 3 squared. Then negative 3 minus 1 gives me negative 4 squared. So it's negative 4 minus a negative 1 gives you negative 3 squared. Negative 3 minus 1 gives me negative 4 squared. So it gives me the square root of 25, which is 5. Now let's find DF here. 7 minus 3 is 4 squared, plus 5 minus 2 is 3 squared. This gives me the square root of 25, which is 5. So this will be yes. Of the beast. Number 6. Finally. AB, you got 1 minus 2. Gives you negative 1 squared. Then 6 minus negative 3, which gives you 9 squared. That gives you the square root of 82. DE, 4 minus 5, negative 1 squared. Negative 2 minus 5 gives me 7 squared. Negative 2 minus 6, dang, gives me 8 squared. So it's 4 minus 5 and negative 2 minus 6. Gives me negative 8 squared. Either way, this gives me 65. And so those are not equal, so that would be no. Sheesh. Number 7. AB. Start by 2 minus 1, which is 1 squared, plus negative 4 minus 1 is negative 5 squared. So it gives me the square root of 26. And DE is 4 minus 5 squared, so negative 1 squared, plus negative 2 minus 6, so give me negative 8 squared, so give me the square root of 65. So that is going to be a no as well. Wait, for DE, that's not like crazy. DE is 9 minus 4, that's 5 squared. So that is going to be square root of 26. So that's good. BC, you do negative 4 minus 2 gives you negative 6 squared, plus negative 2 minus a negative 4, which gives you 2 squared. So it's 36 plus 4, which is square root of 40. And EF equals negative 1 minus negative 2, which would be 1 squared, and negative 7 minus 4, which would give me negative 11 squared. So give me the square root of 122. Negative 7 minus 4 gives you 11. And then negative 1 minus negative 2 gives you positive 1. Yep. This thing is killing me. Like, my eyes on this screen are just playing tricks. Look, I jumped up into this problem. This will be 3 minus negative 3, which would be 6 squared. Negative 6 squared. This will be 8 minus 9, which will give me negative 1 squared. Which gives me 30, square root of 37. So still no, but it's just not the way I thought it was. Whew. Time to get out of those ones. When they stack problems like that, man, it just messes my eyes up on the screen. I can't do anything with it. Decide whether the figure is stable. Explain your reasoning. I don't see congruent triangles there. And so I'm going to go no and no. 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 It's not broke up into congruent triangles. Unless. This is that thing again. Is this actually like a little triangle here, or a big triangle here with a little on the side? Or is this like a pyramid? Tough question. If it's a pyramid, then it would be yes. But if it's a triangle with a little triangle, then it's going to be no. All right, number 9. If this was like a wedge of cheese, it still wouldn't be good, because it's not congruent triangles on the side. So either way, it's a no for that one. On number 8, if it is a pyramid, then it is stable. Are they messing with me? Describe and correct the error in writing a congruent statement for the triangles in the coordinate plane. So they said JHI is the same as JKI. This is actually a pretty easy one to fix. JHI is congruent to triangle IKJ. And the reason that is this goes over 4, up 3, and this one goes up 3, over 4, so that our distance is the same for those two. And this one is the same as this. So this one is actually congruent to that. That one is congruent to that one. So that one wasn't bad to fix. All right, on the back. Now they're giving you reasons first, and then you're going to write the statements to go with them. So first you could say HI is congruent to JK because it's given. And IJ is congruent to KH because that's given. Then the reflexive property says that anything is the same as itself, and that's going to be that middle one, which is JH congruent to JH. Then 4 is triangle HIJ is congruent to triangle JKH. So I'm going to throw this out there for you because I have this sneaking suspicion that most of you are not going to watch this video. I'm going to put this exact proof on your test. All you have to do is write this down in your notebook and copy it over. But how many people are really going to make it to minute 42 of 4.3? So for those of you who made it this far, this is going to be on your test. Matter of fact, I'm going to do that for every section. I'm going to put a problem on it. I'll tell you which one it is. I'm writing it down in my notebook right now. 4.3, practice C, number 11. Boom. Going right on your test. Number 12, complete the proof. Given. So we're going to go WX is congruent to YX. We can say Z is the midpoint of WY. Definition of midpoint means that we can then say WZ is congruent to YZ. So now those are congruent to each other. Then I already have two sides, and I have this shared side in the middle. So by reflexive property, ZX is congruent to ZX. Then triangle WXZ is congruent to triangle YXZ. By side. Find all the values that make the triangles congruent. Let's see. So I can have this equal to this. So let's set that equal first. 6x minus 7 equals negative x plus 14. Now you just solve it. Gives you 7x equals 21. So x equals 3. That's one possibility. Another possibility would be 7x minus 12 equals 2x plus 3. subtract 2x over, gives you 5x, add the 12 over, gives you 15, x equals 3. Now there is a last opportunity. See, we assume that this was congruent to this, and this was congruent to this, but there also exists this possibility where this is actually congruent to that. And so we have to do that last one. 6x minus 7 equals 7x minus 12. It's going to give us, we'll subtract 6x over this way. So it'll give us negative 7 equals x minus 12. Then add the 12 over, you get x equals 5. So those are all your possibilities.